Hi everyone, my name is Kartini from University Malaysia Perlis. I am going to talk about my project. The title is Green Photocatalyst for Self-Cleaning Mixed Matrix Membrane. As we know, water quality has deteriorated over time as the evidence shows that escalating level of various toxic organic and inorganic compounds in both ground and surface water, including some sources of natural organic matter, which is made up of humic acid. As indeed, humic acid is carcinogenic and very dangerous. Therefore, the removal of humic acid of water body has got much attention for its environmental and health concern. There are many methods to remove humic acid in water. However, membrane technology is the best technology to use. But still, there is a major problem in membrane technology. For example, humic acid deposition can cause membrane fouling, a major challenge that restricts its application. Membrane fouling can reduce permeable flux across the membrane, increase operating pressure, and reduce the lifespan of the membrane, consequently incurring higher operating and replacement costs of membrane. To overcome the problem, we apply photocatalytic technology in the membrane. According to previous researcher, hybrid membrane, for example, we add in photocatalysts such as TiO2, graphene oxide, zirconium oxide in the PES hybrid membrane. It appears to be a solution with higher fouling resistance, higher flux across membrane, and higher retention of pollutant. In short, from recent researchers, it is contestable that the performance of hybrid membrane will significantly be improved as compared to the neat membrane. When we add in photocatalyst layer on top of the membrane surface, and then we irradiate with the UV light, electron and hole pair is produced. Due to their activated state, the electron and hole perform chemical reduction and oxidation as though they were highly reactive reagents in chemical reactions. Then, hydroxy radical and superoxide radicals are producing, and it will degrade humic acid deposition on the surface of the membrane, and it will make the membrane perform better again. As you know, the TiO2 is the most used by most of the researchers in photocatalytic application because it recognized for its stability and the most active photocatalyst. However, it has higher bandgap energy that will decrease photodegradation efficiency. So it comes with the new and more sophisticated group of photocatalytic active compounds are known as polyoxometalates. POM as unique cluster with metal and oxygen which arranged in three-dimensional structure exhibit wide range of function that can be utilized in various field applications. When polyoxometalate absorb UV light, it will produce oxidizing agent that have lower bandgap energy with 2.63 volt. It provides larger surface to highly distribute the active site which influence the catalytic activity and selectivity, which will increase the reaction rate of degradation of humic acid. This is the method how we prepare the novel green POM photocatalyst in PES membrane. First, we synthesize POM by using sodium tungstate and nitrophenyl. Acid was added and there will be formation of light green precipitate. Rinse the precipitate with water and ethanol and later were added to PES membrane that was prepared by phase inversion technique. And the mixture was casted and dipped into the deionized water. And later you can see that POM PES matrix membrane were prepared. To test the membrane, we use this filtration system. This is the SRD result for polyoxometalates. As you can see, the appearance of this peak at the same time validating the synthesis of POM photocatalyst is a Keggin-type structure. And this is FTIR result also confirm the same thing. Major fit features at the Keggin structure can be identified at the peak 8886, 958, and 1082. As a result, the basic geometry and structure of Keggin anion can be confirmed with these three peaks observed, and the combination of SRD and TIR FTIR result have proven the Keggin-type POM was synthesized successfully. These are the ACM results for homology of the PES-POM membrane. A would be the neat PES membrane, while others pictures shows that the pictures of PES membrane with different weight percent. As you can see that the membrane physical morphology, there is no considerable difference between the pore size and porosity of the membrane. Nevertheless, a more obvious crystal structure and higher amount of POM were observed in figure D, and the membrane surface with higher dosage of POM in casting dope. For the first 30 minutes, region A, similar flux were observed with insignificant difference. As in region A, the feed was just the same as water. After 30 minutes, region B, the feed was replaced with humic acid solution for filtration until 150 minutes. The neat PES membrane showed a drastic drop among the membrane prepared. This means that neat PES membrane was easily fall, and compared to the POM-PES hybrid membrane, the greater hydrophilicity properties of POM-PES hybrid membrane were less susceptible to HA fouling by entering water molecule on the top of the membrane surface. So in the region D, you can see the FRR value will raise up to even greater, whereas after UV radiations. This effect should not be applicable to neat PES membrane as it does not contain POM. Based on figure, the POM-PES hybrid membrane had outstood the neat membrane in terms of FRR. This means that self-cleaning function and anti-fouling properties of the photocatalytic membrane via UV emission has been established. As you can see, this table shows the comparison of our research work and with others researchers. As you can see that POM-PES membrane gave higher flux recovery with lowest cleaning time, only 2.5 minutes compared to other 60 to 600 minutes. So therefore, it can be seen that our mixed matrix membrane enhance the membrane lifespan, lower membrane cleaning and replacement costs, and no membrane downtime for cleaning or replacement. For the future application, it can be used for separation of organic pollutants, drinking water treatment, and also for wastewater treatment for organic compound. So the novelty is it was the first ever attempt to incorporate Keggin-type POM synthesized by sodium tungstate and nitrophenyl phosphate in PES membrane for photocatalytic ultrafiltration membrane. As you can see, we also have publication on this study that published this year 2022 in Korean Journal of Chemical Engineering Technology.